Hello students, welcome to this session. In this session we are going to do product of vectors. What about product of vectors? Product of vectors is not like multiplication of two real numbers. So two different type of products are there between two vectors. One is a scalar product, another is vector product. If we talk about vectors, vectors are quantities which have magnitude, which has direction, and it has also satisfy the law of addition. So what you have to understand here, that there is one which is called a scalar product and it is also called dot product. So a scalar product is a product where when two vectors are multiplied you get a scalar quantity, and another one is vector product. Vector product is a product which is also called cross product, and here when you multiply those two vectors you get a vector quantity, that means it has a direction. Now if we take first, which is basically a scalar product. So a scalar product of two vectors is written like this: a vector dot b vector. So this is a scalar product, there is a dot between a and b. Now what is this value finally? This value is magnitude of a into magnitude of b into cos theta. What can you tell about theta? Theta is the angle between the two vectors a and b. So this is a vector a, this is a vector b, and there is an angle between them which is theta. So this theta will give you some cos, and cos theta will be multiplied with mod of a into mod of b. Now for example, if I say that there is a vector a which is 2I cap plus 3j cap minus k cap, and this is b vector which is 4I cap plus k cap, and you have to find a dot b. So in that case, how do you find a dot b? So this is when the vectors are given in component. So you write as 2I cap plus 3j cap minus k cap into 4I cap plus k cap. Now when you do the dot product, what will happen? That 2I cap dot 4I cap, what would be that? 2 into 4 will be 8, and I dot I. So the angle between I vector and I vector is 0 because they are parallel vectors. So cos 0 will be 1. So what would happen? I dot I would be 1 because 1 into 1 into 1 will be 1, cos 0 is also 1. So this will be 8. If you talk about 2I and then dot k, so what will happen? I dot k, can you tell me? Yes, the angle between I and k is 90 degree. I is a vector which is along the x axis, k is a vector which is along z axis. So the dot product will be cos 90 degree, which will be 0. So this will be 0. What you will say? This will not contribute to any value here. 3j cap dot 4I cap, again I dot j will be 0. What will happen? 3j cap dot k cap, that will also be 0. What will happen? Minus k cap dot 4I cap, that will be again 0 for the same reason. Minus k cap dot k cap, that will be minus 1 because k cap dot k cap will be again equal to 1. There are parallel unit vectors. So this value will be 7. So one thing you have to remember, the result here is that I dot I, or you take j dot j, or you take k dot k, you get always 1. And if you take I dot j, if you take j dot k, you take k dot I, you get always 0. And what about if you reverse them like j dot I? So j dot I will also give you 0, because you have to remember that the two vectors a dot b are actually same as b dot a. The dot product is commutative. This you have to remember, that dot product is commutative because it does not have any direction. So if it does not have any direction, then a dot b will also give you mod a mod b cos theta, b dot a also give you mod a cos theta, and multiplication is commutative of real numbers. So if this is what we have to know. if suppose it is asked that find the angle between the two vectors A and the vector B. So how can you find the angle between those two vectors? Again, by the definition of dot product, as you can see here, that A dot B is equal to mod A mod B cos theta. So can you say that cos theta is equal to A dot B by mod A mod B? Can you say like this? Of course you can say like this. Now if you take again the example which we have taken here, these two vectors, can you tell the angle between these two vectors? Cos theta. So cos theta would be equal to A dot B. Have we found out A dot B? So A dot B is equal to 7. So this would be 7 here upon mod A mod B. So can you find out mod A mod B? Of course we can find out mod A mod B. So from here mod A is equal to root over 2 square plus 3 square plus minus 1 square. So it would become 4 plus 9 13 plus 1 14. So root over 14. What about mod B? Mod B is equal to root over 16 plus 1, that is root over 17. So root over 14 into root over 17. So this is how we can write root over 14 into root over 17. So this is cos theta, which will give you theta, which is equal to cos inverse of 7 by root 14 into 17. Whatever the value you can calculate and you can find the final result. So this is how you can find the angle between two vectors. So you have to remember few things. What are those things? First point about the dot product, that A dot B is equal to mod A mod B cos theta. Another point is that I dot I is equal to J dot J is equal to K dot K is equal to 1. Another point, I dot J is equal to J dot K is equal to K dot I is equal to 0. Another point, that dot product is commutative. A dot B is equal to B dot A. Another point, that if you have to find the angle between the two vectors, then it is theta is equal to cos inverse of A dot B by mod A into mod B. So these are some important points regarding dot product. Now we will see the application of dot product. So first application of dot product is projection. So if we project a vector A on another vector B, so this vector is A vector and this vector is B vector. We are finding the projection of A on B. So projection of A on B would be like this. We drop a perpendicular here. This is the angle between these two vectors, which we don't know right now. Now this is the projection which we have to find out the length. So can we say that this is the magnitude of A? Of course. So this projection would be mod A cos theta. Now we don't know what is theta, but we know how to calculate cos theta. So can we say mod A cos theta is actually mod A and cos theta is A dot B by mod A into mod B, and mod A would get cancelled, and what do you get here is A dot B by mod B. So this is what we are getting here. This is the projection of A on B. So if you can write it like this also, then also there is no problem. A dot unit vector B, because B vector by its magnitude is unit vector B. Now next thing is basically, if it would have been asked what is the projection of, this is projection of A on B, right? Projection of A on B. Now can you tell me, if it has been reversed like projection of B on A, what would be the answer? So if projection of B on A would be there, then it would be B dot A cap. So here it is A dot B cap, here it is B dot A cap, and a projection would be something like this, that this would be projected here, this one, and in that situation this would be the length, that would be B mod cos theta. Next we have another application, that is if we have been given a parallelogram and it is asked that its area is to be found out and the adjacent sides are vectors A and B and the angle between them is suppose theta, which we again do not know right now. So can you find the area of this parallelogram? This area we have to find out. So how do you find the area? Area is parallelogram base into height. So what is its height? Geometrically, if we see the height, this perpendicular, this is height h. So base into height, that is magnitude of A into h. This is having length, magnitude of A. Now h is basically, this is theta and this is B vector. So this is magnitude of B, the length is magnitude of B. So we can say that sine theta is equal to perpendicular upon hypotenuse, that is h upon mod of B, that is h is equal to mod of B sine theta. So this is h. So let us substitute it here. So A mod into B mod into sine theta. So this is the area of this parallelogram. Now how can we write this area? Now come the concepts of vector product. So we will come to vector product law or the cross product. Till here we have the formula, but how to express sine theta? We now know what is cos theta, but we do not know what is sine theta. Of course, we can find from cos theta, but that would be a lengthier process. So this application was application of the dot product, which is the projection. Next application, which I have told you just now, is the application of cross product, which is vector product. Now if we take the cross product A cross B, this is A vector mod into B mod into sine theta and n cap. So if this is a vector A and this is a vector B, this is the angle between them, then the cross product of these two vectors is basically written like this. Now how do you define this n cap vector? The direction actually. This is the direction. So how you define that? So for that we have to use right hand thumb rule. So we place our hand like this on the first vector A and then move right hand and then move towards B like this. Then the thumb will point towards the direction of the cross product resultant. So it is inside this plane of the board. So this is the direction. It is perpendicular to both A and B, that is inward. If the vectors are like this, suppose this is A, this is B, and then you have to find the cross product, then A would be here and then you will move it like this, the thumb will point outward. So it is outward, perpendicular to the plane again, but it is outward. Here it is inward, here it is outward. So A cross B, here it is inward to the plane and here it is outward to the plane. Rest magnitude part, this magnitude part is same, either you take A cross B or B cross A. One thing is to be clear, that A cross B and B cross A are not equal, rather A cross B is minus of B cross A. So this is something like this, that is there is a difference of direction. The magnitude of both of them is same, but the direction is opposite. One is inward, another one is outwards. For here if we take A cross B, it is inward, and if we take B cross A, it is outward. Here if we take A cross B, it is outward. Here if we take B cross A, it is inward. So I am writing here inward for A cross B and I am writing outward for A cross B. Okay, for B cross A it would be just opposite of what it is for A cross B. So this is the result first which you have to remember for the cross product. Now if you want to find, suppose we have a question that there is a vector which is 2I cap minus j cap plus 3k cap, and another vector B and it is j cap plus k cap, then can you find the cross product of A and B? So here again one thing has to be kept in mind, then while we are doing the cross product, what happens to its unit vectors along x, y and z, that is I, j, k. So if you see here, there is some rule which we need to follow. The rule is, if we take I cross I, or we take j cross j, or we take k cross k, so all of them are equal to 0 actually, because the angle between I and I is 0 and sine 0 is 0, j and j is 0, sine 0 is 0 again, k and k is 0 and sine 0 is 0 again. Whereas if we talk about I cross j, what is the formula for A cross B? Mod of A mod of B sine theta n cap. So I mod is 1, that is a unit vector, j mod is 1, it is a unit vector, sine 90 degree, because angle between j and I is 90 degree. So sine 90 degree is also 1. What about n cap? So if you take I and j, what will be n cap? Suppose this is your x axis, suppose this is your y axis, and suppose the outward vector from this plane is the z axis. So this is the z axis. So this is the x axis, this is the y axis, and this is coming towards you is the z axis. Now if you take I cross j, this is I unit vector, this is j unit vector, and this is k unit vector. So I cross j would be k, of course. So I cross j would be k vector, because its magnitude is 1, only direction is there which is k. Similarly, j cross k is equal to I, and k cross I is equal to j. So these are the some of the results we have. Now if it is reversed, like I am not taking I cross j, I am taking j cross I. So what would happen? It would be minus k, of course, because A cross B is minus of B cross A. In other words, j cross I, it would be inward, opposite of positive z axis, that is negative z axis. So you can remember this result by a circle like this, and take I here, j here, k here, and if you go from I cross j, you will get k. If you go from j cross k, you will get I. If you go from k cross I, you will get j. But if you proceed in the opposite direction, that is you take j cross I, you will get minus k, I cross k, you will get minus j, k cross j, you will get minus I. So this we have to remember here. Now let us see what is A cross B. So here I have taken 2I minus j plus 3k. So this is 2I minus j plus 3k, and we have j plus k. This is a vector A, this is a vector B, and then we have this A cross B which we have to find out. So A cross B is 2I minus j plus 3k cross j plus k. Now 2I cross j, that would be k, so 2k. 2I cross k, what would be that? That would be I cross k is minus j, so minus 2j. Then j cross j will be 0, then j cross k will be I, then k cross j will be minus I, and then k cross k would be 0. So what we are getting finally is minus 4I minus 2j plus 2k, like this. Now let us take this in determinant form. How we take it this in determinant form? We take it like this. This is a determinant I, j, k, and the component is 2, -1, 3, here 0, 1 and 1. So this is also a way in which you can write it in short form, but this value and this value would be same. It is not different. You can check also. I am checking it here. So ijk is there, ijk is there, and then we have 2 -1 3, and then we have 0 1 1. So this would become equal to I -1 -3, that will be -4. So -4 I cap. Then minus j cap, 2 minus 0. So -2 j cap. Then k cap 2, so plus 2 k cap. So what do we get? -4 I cap minus 2 j cap plus 2 k cap. So -4 I cap minus 2 j cap plus 2 k cap, same result. So you can say that two vectors A cross B is equal to I, j, k, A1, A2, A3, B1, B2, B3. These are the components, right? Now, if you talk about a while ago, we were discussing the application of multiplication of vectors, and we came to this conclusion that area of the parallelogram is mod A into mod B into sin theta. So here you can say it is mod A into mod B, and what is sin theta? It is A cross B by mod A into mod B, and take a mod of A cross B, because we don't want the direction here, because area does not need direction. What do you mean this? Because here sin theta is A cross B upon mod A into mod B. So I am writing sin theta is A cross B upon mod A mod B, and I am not taking this unit vector n, I am just taking the mod both the sides. So if you take mod both the sides, this is also mod. So this is already mod, this is already mod, and this sin theta we are taking acute angle. This mod will be equal to 1. So what would happen, that this sin theta would be written like this, and you will cancel A mod B mod, and you will get finally this as mod of A cross B. So this is an application of cross product of vectors, that is the area of parallelogram whose adjacent vectors are A and B has area equal to A cross B mod. So that is all for today's session, students. We will come to some new interesting sessions in future and catch up again. Thank you.